Suppose we have a graph like this. Then we see that in this portion the set of nodes shows a more similar kind of connectivity. Similarly, in this portion node shows more similar kind of connectivity. This kind of set of nodes are called community. If we represent a social network through a graph, then we can identify the communities. General behavior of community is the similarities inside the with respect to other set or community. This means the nodes in this set are more similar with respect to the entire network, and similarly nodes in this collection or sets are more similar. This similarity can be measured by using the distance or density of packings. Community detection is very important in social networking. You may find several communities like for example, suppose we represent author and citation, author with title of paper, and citation, and prepare a graph, and then after identifying the community we will find the papers having similar topics. Means here community detection will result in paper related to similar topics. Similarly, in a general social networking, by identifying the communities, we can identify the social behavior. For example, we can group the people who like to study only physics, and similarly we can group the people who are interested in some particular games or sports, etc. But to identify the community, first we need to represent the entire network through graph. Now I will discuss about some algorithms to identify the communities. Generally two kinds of algorithms. First is known as divisive algorithms. And second is hierarchical algorithms. In divisive algorithms, we consider the entire set of nodes as a single community. And then break it continuously by using some measurements and parameters. The most famous algorithms of divisive kinds of algorithm is using edge betweenness. Edge betweenness based community detection algorithm proposed by Girwan and Newman, also known as GM algorithms. I will describe how I can calculate the community by using this algorithm. Next, I will go through the hierarchical algorithms. The Girvan-Newman algorithm or GM algorithm first identifies the betweenness. To understand the notion of betweenness, we will create a graph like this. In this graph, we see that this edge is more between than this and this edge. So, first to understand what is betweenness, edge betweenness can be defined as the edge from which more number of shortest path passing through. For example, suppose we take this edge, then through entire network, how many shortest path will pass through? Suppose if we take the node 1 and 2, then number of shortest path that pass through 1 and 2, I think it will be only 1. But if we take the node like 4 and 5, then number of shortest path, I think it will be very high, because most of the nodes in this side and this side requires this edge as a shortest path. So more number of shortest path will pass through this node. So the node which connecting the node 4 and 5, and so the edge which connects the node 4 and 5 will be very high edge betweenness. So in Girvan-Newman algorithm, we just break such kind of edges and then recalculate the betweenness. Now the steps can be written as calculate the and step 2, first of all I will calculate the betweenness centrality of all edges and then remove the edge having highest betweenness centrality. So here we will remove this, and after that we we will recalculate the age betweenness for entire ages. And suppose after removing this, I think this age or this age may show the highest betweenness score. Suppose this age shows the highest betweenness score, then we will remove this, and again we will calculate the betweenness centrality. So step 3 will be and step 2 until a certain threshold is achieved. To maintain the community with a certain strength or certain characteristics, we need a measure called modularity. We can fix the modularity, means what amount of modularity we want in this community structure, or it will be suitable for our system. We will fix by using this modularity score. But before going to discuss about the modularity score, we will analyze this algorithm. If we use the fastest version of Newman's algorithm to calculate the betweenness centrality, then it will show the time complexity of OMN, where M is equal to number of ages and N represents the number of vertex. But the problem is we repeat the step 1 and 2, so we will apply this algorithm multiple times. Then our algorithm, due to repetition, the time complexity will be now we can improve this time complexity criteria. Suppose after removal of this age, we see that not the time complexity, not the betweenness centrality of all ages are affected. For example, betweenness centrality of this age will not be affected, this age will not be affected. So for improvements of this time complexity, we can consider this fact. We will recalculate only those we will recalculate the betweenness centrality of only those edges which are affected through this removal or after every removal. This will, I think, reduce this time complexity to some level. Now another idea may be like calculate the betweenness enthalpy of all edge ones and use it for several breaking. But this idea will fail. Suppose after removal of this edge, we will use same betweenness enthalpy. Then in some cases it may create some wrong result. If after removal our betweenness, if after removal the betweenness score of some edges changes, then it may give some wrong result. Now I will go through the modularity score. What is modularity? And the modularity score of any community set of communities can be given as Q is equal to LS divided by L minus DS divided by 2L where M is equal to number of modules in partitions L is equal to total number of links in the network LS represents number of links inside the module S and DS represents the total degree of nodes in module S. Now we can calculate this. Suppose after removal of this edge and this edge, we have two communities, this and this. So in this case, value of M will be 2. L is equal to total number of links in the network. You can calculate the total number of links. Here it is 1, 2, 3, 4, 5, 6, 7 and here it is 1, 2, 3, 4, 5, 6. So L is equal to 13. Now for this portion s is equal to 1, and for this portion we take s is equal to 2. So LS1 will be number of links inside the module S. Number of links inside the module S, it will be 6, and LS2 it is 7. Similarly, DS1 total degree, here it is 2, 3, 3, 3 and 1. Just by putting we can easily get, and similarly DS2 is equal to 2, 4, 3, total degree 3, 3 and 2, 6. So here the modularity score Q will be LS1 divided by L plus minus DS1 divided by 2L plus LS2 minus DS2. Just by putting value we can calculate, we can get the modularity score for this partition. The higher the modularity value indicates, the higher the tightness inside the community with respect to other outside communities. Now after this I will go through some hierarchical algorithms to identify the communities. ब्रेक कर दीजिए.